just wanted to go and say like, okay, what can you guys maintain? What do you miss? I don't want to be, in a position but just throw something over the head. It's like, we can do whatever we want. This is what we came up with.
No, yeah, no, I get that. I mean, typically, all we have to do is say, if they provide us like a toler or a node or an environment, it doesn't, they should give whatever we have. We should not.
This
And
is
then it
why
runs with a node or has the ability to run with a node.
he reached out and he was like,
I mean, yes and no, because the thing is like,
we got an emergency.
when it breaks, a letter to them. So if they don't,
We get the picture phone.
you guys do that.
Yeah, we get the picture phone.
No, so not everything goes through that.
No, if we have our own pager dealer set up, like things don't work or whatever, we get the thing. And then we would then look up with.
Is that the norm, or you guys kind of an outlier on that?
I don't know, because, you know, it's like we have the keys to our Jenkins notes too. I don't know how to fuck with Jenkins, added, you know, some environment variables, but I don't know what I need, so I need. She did say that we have the keys to everything, and that we can do what we want, but she would not be happy, or DevOps would not be happy if we go in and break things.
After that, they said, actually,
Which is granted, which is fine, like, hey, you give us the keys, there's a responsibility, right? Like,
Great tower.
exactly, yeah, so I can respect that, and I'd rather have the freedom to do that.
tell me something that you.
Yeah,
My hands tied.
that's kind of the same thing when we asked for, AWS, so it's kind of like, we can give you one to mess around with, it will not be public facing.
And then after that.
You can be on your own and do whatever you want, or we can manage it for you, it's gonna be slower, you know, getting it running, it's wrong.
Yeah.
It's gonna be a low priority, because you got no production. I'll take the rest.
So, okay, yeah, I mean, so like my suggestion to that would be like, I have my own free tier AWS account. I've done use that for meetings, my work, while I'm waiting for DevOps to get his thing. So.
Did he just hear?
Mario and I joke that,
Because the shared web was it's 5.1 or something.
yeah.
I should have
And our entire defense side of this,
it was always disappointing. Like if you like, jump on everything was ready. So actually, gave it the first time.
Your whole parts, right? Like,
Gave it like 2 days later. My computer would not connect to any projector. We had 4 rooms go. None of them. Their projector in the hotel. Didn't work on my computer. And this was like, my computer is gonna work.
You don't understand what you're
So I get up and give it a long time about nothing hard. Well, it turned out really good because it's like, okay, so
Like,
like,
guess what?
well,
I guess
computers
what?
are all concept.
Swedish.
Because I was sitting on a table with a blank screen.
Cheers, next time. This be a studious.
So this is right. People really engaged. That's not so very good because everyone like felt like they were in it too.
Sure.
Because it was like, adventure time.
Oh, yeah, sure. Gotta use it right.
So what's this? What's this? I like that.
I mean, you got, well, I guess actually it's not as many as I thought. It's,
Robbie and one of my friends didn't work in
yeah, because I forgot everyone else went back to Dell. Yeah, that's right.
Where he's written us. He gives it all.
Adam's Adele, Mike's
It's like Maisa is at, no, it's not, she's not at the whole, she's at that, company.
Oh, that's right. The one that like, she, yeah.
Expand or something.
They had to like lay off like 50% of their workforce and then now, but now they're doing better, so it's like to rehire again.
This feels used.
Yeah, whether, or they just CO2, right?
Yeah.
Yeah, sure.
Sounds like, my cousin left it in the van presentation.
Okay.
So they're totally not
Absolutely with this. Yeah, I actually have a couple of these on my bike right now. So.
Really?
Yeah. Use these as spares. You just randomly show up with freaking CO2 canisters.
My cousin was here and he's, I knew he was alive. Serious with you both. Yes.
Cheers.
Cheers. They have a pastor on sides all the time. So is it to India again?
Hopefully soon.
Yeah?
Maybe the 2017. The boss man said so, so they're quarantined.
Or are you making them come over here completely?
We've had 3 of the guys in this month alone, so like, he's the 3rd visitor we've had this month.
Yeah?
Unless we have the San Francisco office now, so it's easier to make that hop than it is to make the India hop.
Okay. So how come I haven't seen a company in NASDAQ yet?
Well, we just announced our Series A like, I don't know, 2 weeks ago, was it? Wall Street Journal.
Is it? Okay.
Not enough attention yet.
Yeah, not making enough noise. Not making noise right now.
It's called stealth mode. Stealth mode.
He basically
Actually, it was working.
terrible mistake.
They're not the right, they were an exception. They're not the right usual sample.
Yeah, we talked about the whole APP thing. It's an old, like, way behind the times company that decided to like have a mobile division and then like completely failed to manage properly. So then 2 years later, the division was laid off. Like, all right, well, it's fun.
No, they would have had a comeback if they had just properly
This is 2000.
the thing is,
Keeping in touch with Randall. Just turned 8 years old. Yeah, birthday was last weekend.
You heard India?
Yeah.
Most were the most users say.
Yeah, the first like 3 or 4 are just.
It's only for parents.
Yeah. Well, you know, there's no sense in having like the kid doesn't even, not only not going to remember the birthday party, he doesn't even have any friends at that point. Like, you can bring over other babies, it's not like any of them know the difference.
that's the point. That's absurd.
Yeah. Yeah, the kid hasn't dashed the parents' hopes yet.
You don't really know that your child's a failure until they're later.
Not until, you know, they start dressing goth and, listening to Nickelback, you know, like, it's like,
That's how my kids
And then they did an arrow the next
I dated a girl, 4 years ago, and she was, straight laced, she was a programmer, she worked, you know, office job, long hair, like, glasses, you can see, whatever, right? But then you look at all her high school photos, she was goth, and her hair was like black, and the skull, like, shirts on, and the piercings, and like, so I go with you, and, But now she's like doing the college. I think going to college was straightened out and realized that she should be taking it seriously in computer science. Like a businesswoman, so now she wears her pantsuits and
So the framework, what do you?
Andrew is doing tons of React. I've managed to fend off that demon for a while. I'm still doing a lot of sales.
All the tools.
I'm all server side, right? So I'm doing Node and sales.
How come I thought you were never for sales?
I'm not super fond of it, but it's I'm using it.
So far as it keeps you happy or?
It keeps the production servers up and running, so I guess it can't be that bad. It's able to serve all of our traffic, so it really matters.
Reaching into the plumbing side, so that you can.
But, So I ran this quiche maybe 2 months after we started. I was supposed to write about height of my like, I hate sales. It was before I had kind of reached the zen that I'm at now, which is kind of like, I've learned to work around it. You know, like back then it's just like,
Somebody has to try it.
But the last presentation, I was just like, sales, man, sales, it blows. Yeah, there was that period where I actually thought sales was great. So well, it's the rad thing, right? Like, anytime you encounter any rad tool, the first few days or weeks, it's really helping you move stuff faster. But then you start running into limitations, and you're like, fuck.
Or somebody else buys them. Yeah.
So, have you been looking at or keeping tabs on WebAssembly? Oh man, that's the future, dude. 2 years from now, 2 years from now, JavaScript's gonna be on its way out. WebAssembly's gonna be where it's at. Just like everything is changing. Like WebAssembly is going to change the software landscape bigger than Node ever did. Do you think Node had an impact? WebAssembly made all of this shit crazy, man. Imagine like literally any language, Java, Cobol, C++, whatever, can run on any platform out there. IoT devices, mobile, server, client, in the browser. Freaking C++ in the browser.
Yeah, okay.
There's already like PVCs that are running like Quake 3D and stuff in the browser using
It's like, this is. Did you hear about Netflix?
What about?
They have this Zoom, right? It's completely down-raised. So recently they switched it. I mean, like,
Oh, I know Netflix has been switching a lot to which is single threaded. Is that what you're talking about? Or?
Right.
Okay.
Completely, and it was a big change for them.
Well, so Netflix has been moving all their stuff to Node, right? And so they were on Java, which is all multi-threaded. Now they're on Node, which is single threaded. So they're having to redo their architecture from instead of big monoliths that have multiple threads, to tiny little microservices which have a single thread. And they've run into some problems. Like I was actually just reading the other day about one they ran into, because I follow their DevOps account, and their DevOps team has a blog where they just post like all their fails. It's really great. And one of the ones they ran into was So they were doing a thing where every time a request came in, they dynamically, rather than just having handlers like you do in sales or express, they would do something about the architecture. They actually created a new handler function for every request that came in, right? And that would be a problem if they were properly disposing of the handler function. They weren't. So what was happening was they had this big object that slowly, started off with maybe 100 functions, then it had 1,000 functions, it's 10,000 functions, right? And you're just doing a by value or a by value. You're really saying this object has a property thing, this, it's got some ID. Just looking up the key on an object that has 10 million, property or whatever, ended up taking so long that it takes like more than half of the requested time was spent just finding the handling for this thing. And so it was of course blocking because it's single threaded, it was blocking everything else. So they're what's it called? Effectively, the backlog was getting too big. Yeah, so it turned out that it was a simple fix. They ran a profiler, it's all the memory leak. But the important thing was because it wouldn't have been a problem in Java, right? Because in Java, even if you did have an object with 10 million keys on it, the finding of the thing would have been done on its own thread. Other threads are just capturing requests, right? So with Node, you cannot have something like that. It just stops it.
We're here.
I don't know, it's kind of interesting.
Okay, we're still waiting on projections.
The thing that Netflix really does, and I actually think a lot of it's in our basic Node, which is the dirty little secret is Netflix actually hasn't gotten rid of all its job. The Node stuff is just sitting in front of the job. And I think that if you look at the big companies that are using like Capital and Paper, I bet you they're doing the same thing. They still have a bunch of Java web services. So they still got these modular but they now have microservices for all of these services. So they're just all the commodities. I have one myself. Everything is terrible. That's Andrew's like summation of the entire industry. Everything is terrible.
Basically what it is it's just a bunch of documents, Java.
It's Node all the way down. It's going to happen 2 years from now. We're going to have all this WebAssembly layer that talks to your Node layer, that talks to your Java layer. It's going to be like going through like the old fossils of opportunities. At some point, you're going to be hitting Unisys mainframe. You're running COBOL.
That's really good. It's just 3 years from high school.
Back when I was your age, I was 40.
He was the best one here.
Oh, that was nice. Well, he is. I'm not.
Is it
And that's,
that?
here's the thing, is I actually like this reactive sharp, right?
This is one right here.
The-
So what
Yeah.
I've gone through some ways.
I was told like 7 yeah, but that's like 2 minutes to. Fanning the neck.
It's very specific design.
That's my time to get
It
started.
has the disadvantage of complexity. You don't read it unless you know that you need it. And so the thing is that I'm convinced that most of the projects that switch to Redux don't really work, and they just like mean that it is price for enterprise, and you know, it's in terms of traditional. There are use cases for it. Facebook's an excellent use case for Flex architectures in general, like the way that their page is laid out, the way that their use case reads that complexity. And there are some other things too, like I even think that maybe the post-Twitter app itself might be a good use case. I'm not fully convinced that what I'm building is a good use case. I've already looked through it and it's an option.
It works fine.
There's no chair. Shoot.
Would you like a chair?
No, but I like sitting down. I hate standing up. When you stand up, everybody looks at you. Hey, everybody. So I am not Keith nor Edward. They asked me to come fill in for them tonight. So welcome to the Austin API meetup. Hopefully that's the meetup that you're here to attend. Tonight we're going to be talking about REST APIs and real-time messaging. Talking with Gordon, he said that it could just be push would be another way of putting it, but push is like such a multi-used word. It's hard to know what exactly you're talking about. So real-time messaging is a little bit better of an indicator. A couple of things that Keith asked me to do. I'm sorry, I'm reading from notes because he was like, make sure you do all these things. One of them, HEX Tech Events. If you're not following it, it's a really good source on Twitter for keeping up with what's going on. It works really good on Twitter. I was with Keith in a Slack team that he was trying out posting to Slack. It's way too much volume for Slack. It's perfect for Twitter. But definitely follow that. Austin API is the Twitter account for this. Of course, there's the meetup as well. Please join the meetup if you're not. Follow the Twitter account if you're not doing that. The sponsor is Push Technologies. They are sponsoring all of the drinks that y'all have been enjoying. So big thanks to them. Announcements. Next month, no Austin API. This is going to be a common theme for a lot of the meetups next month. Next month is AWBASH, or the Austin Web Bash. Last year there was 29 different meetups that all came together over at Buffalo Billiards. We ran out the whole space and had a Christmas party. It's an opportunity to get to meet people in all the different meetup groups instead of just the meetup groups that you go to. So if you make sure to mark your calendars for that. That's the second Tuesday of December 13th, if I remember correctly, is when that's happening. But it's a big fundraiser. Last year we raised $4,000 for Jen Austin, the Girl Empowerment Network Austin. This year I think Chick Tech Austin is the person or the group that we're sponsoring. They're doing a high school program to get high school girls into technology, doing some Arduino stuff and things like that. So the money we're raising this year goes that. I say we because I actually help run the refresh group, so that's one of the things I get to help out with. Let's see here. Next meetup is January 4th. It says we'll figure out the plan before AWBASH. So stay tuned for what's going to happen on January 4th, but that'll be the first meetup of the new year. Apparently there is a speaker lined up because he says they are still looking for a speaker for February. So if you've got something on APIs that you would like to talk about, this is definitely the place to do that. So please reach out to Keith or Ed or anybody else that's helping organize the group. I would assume either via Twitter or contacting the organizers on Meetup is probably your best bet to get that info to them. Let's see here. I'll load your bio now because I didn't have that already ready too. He was like, here's the link for that. Oh no, and the mobile site is just like not giving me that info.
I can do that.
Well, I've got it now, so look, I vamped just long enough to get it. So Gordon McKinney is our speaker tonight. He's the senior solutions architect, or a senior solutions architect, with a history of hands-on technical work in telecoms, finance data feeds, and high-performance messaging. All of those seem like things that I would not want to work in, because I imagine the stress is pretty high.
And it would be okay if they weren't telling you to do it in 5 sprints only.
Yeah, see, I really like my social networking startup company. That's a much, much better pace. But he's here to talk about REST and APIs in the context of real-time messaging. With that, I'll hand it over to you.
Right. My name is Gordon McKinney, as we've discussed. I like a discussion, so as we go through these slides, if there's anything that tweaks your interest, please just fire some questions at me, because I hate just reading from slides. So
Can I get you to talk a little louder?
I'll try.
Thanks.
Is that working a bit better? All right, we'll see.
I've got old ears.
Yeah, I'm English, so that means I'm not going to project as much. So, although I've been in Texas now 11 years, so I've gone almost native. So I now sound Australian more than English. So today we're going to talk about real-time messaging, but before we do, I want to talk about REST. And we've all done a lot of APIs, me included, that are based on REST. There's some great strengths to that, because they can be consumed by pretty much any language, but there's also some weaknesses, and we're going to touch on those today. We're doing all this in the context of, problem apps and dream apps, right? Problem apps are the ones you got out as a minimal viable product, and then suddenly you start getting the static from people complaining about performance and reliability. And we'll go into the next slide here. So how many of you here have done polling-based REST APIs? So an application that's going to keep hitting the server to get the latest information. Okay, cool. So have I. It's the easiest thing to do. It gets the project running, and then you get some good feedback and iterate. But of course, you always wind up with a bit of technical debt then, because then it's a little bit hard to change from that down the road. So the challenge with this approach is you change your data on the server. The clients have to be polling, or you have to swipe down to refresh to get the latest information. And that keeps on going over and over and over again, and more. Lots of polling, and surprised and upset users. So I wanted to dig in a little bit, because I'm very technical. This is a single REST request. This is going to api.nasa.gov to get some random information. So here's the data object, the JSON object. Ignore this stuff down here. We're looking at around 30 packets just to get 1 kilobyte, about a kilobyte of data. So we've got maybe 15 round trips. We've got sessions set up for the socket. We've got SSL set up all the way down here. Oh, there we go. So we're 2/3 way down this packet trace, and there's our application data. And then we shut down the socket. And this happens every time you make a single REST request. Now, in this case, this is using cable and Wi-Fi, so ideal conditions. And it took 440 milliseconds to get that. In which case, you go, so what? That's not bad, half a second. When you start to do this with a mobile network, it changes significantly. So this is network link condition on a Mac. I've put in 10% loss, 1,000 milliseconds round trip time, which is actually reasonable. That same REST request takes 9 seconds. A couple of retransmissions there. 9 seconds to get 1 kilobyte of data. How many people here would be willing to wait that long? About, let's have a look, what is this? It's about the sun, there you go. So would you wait 9 seconds? In fact, I think I paused almost 9 seconds there, not intentionally. So we've got to have a better answer to this. We'll come to that in a minute. So this company here, we're going to make the slide deck available as a PDF on the website, but I've got references here so you can go digging and finding this information. But this vendor here, Load Impact, has a wonderful little infographic. Of course, they want you to use their software for testing. I can't endorse it, I don't know, I've not used it, but I did like their infographic. So I stole it and then credited them. So here we go. So 60% of mobile app failures are non-functional, and 70% of a mobile app's performance depends on the network. I'm data-driven, so I gathered some statistics. This left-hand chart here was my phone at WeWork, sorry, Capital Factory, just down the road here. So you're in Capital City, right? And this is the performance we get: 156 kilobits download, 96 kilobits upload. And I think the round trip time was in the order of like half a second. On the right here, this was a test at an NFL stadium in Nashville with 70,000 people playing on their phones. I tried to post my selfie to Facebook and it failed. But what I then did was, I took a sip of beer, and then I ran a bandwidth test, which was the graph on the right. 98 kilobits download, 8 kilobits upload. Now, that's shocking when in 1994, as I was dialing into the internet, I had 33 kilobits down, 33 kilobits up. So LTE, 2016, NFL Stadium, we've got worse bandwidth than a dial-up analog modem from 1994. So it's very real, very real. There's challenges when you're out on the public network, the mobile network, in getting your data to and from your application. This is a great chart. This gentleman here, Ilya Grigoric, hopefully I didn't destroy that. He's a web performance engineer at Google. He has a whole blog. I strongly recommend spend some time on there. He also has a book, High Performance Browser Networking, if I remember correctly, which I think is available somewhere for free. I think you can go read that. Fantastic book. He focuses very much on Chrome, browser networking, and websites. This talk is sort of steering that same conversation, but towards your JSON data, the data that feeds your application and the data that emits from your application. But nonetheless, this is great, is the United States. 67% of the time, users are actually on LTE. The rest of the time, they're on 4G, 3G, and Edge in some cases. So it's quite telling. France, 50%. So again, that wonderful app that you've got that's running on your laptop at work, screaming along, isn't going to do it in the real world. So why is this? Now, I spent some time at Alcatel-Lucent, and one of the things they drill into you is this. We've got our internet here. By the way, telecoms, they rename everything. I have no idea why. They can't call it internet, they call it the external network, EN, they give it an acronym. That way, anyone who goes and works in a telecoms company spends the first 3 months learning all these acronyms. You then have the evolved packet core, which we'll just call the provider's network, cell towers, and phone. So here's the deal. Your phone, to transmit data or receive data from a network, has to actually talk to something called the radio resource controller, the RRC. That's the traffic cop. What it does is it decides what frequency, how much power, and when you can actually start talking. Until the RRC gives you a channel, you can't do a thing. So you've talked to the RRC, you've now got a channel, you're talking to the cell towers. Well, as you know, cell towers are over there, we're here, there's steel, metal, glass, water, whatever, between us and a destination, depending on where you are in a building. If you think of yourself at Home Depot, all those great big racks, the building itself acts as a Faraday cage to hold your signal in. So it's a real challenge for the cell towers to hear your phone. Generally, it's not that way the other way around, because the cell tower's got a heap of power that's transmitting from over there, so you've got a very strong signal. But the phone shouting out to the actual towers, it's very difficult for the towers to hear you. So that's your first challenge, is how do you get your signal to and from the towers. The next challenge is this: the cell towers themselves connect to the core network, but they could use a hotline, they could use fiber, they could use a microwave link. You have no idea. Then you also don't know if they provision enough bandwidth on that backhaul link. So now you've got two challenges, and we haven't even got halfway through our diagram yet. You got the EPC. Now, after the talk, well, I'm finally getting a beer, we can talk more about that because there's a lot of stuff going on in there. But the two big takeaways are there's carrier-grade firewalls and carrier-grade network address translation hardware. Multiple layers of that, in fact, which cause all sorts of wonderful behaviors with TCP/IP. For any of you who've done denial of service attack protection or user authentication protection, and you go, hey, if I've had 5 password attempts from one IP address, I'm going to blacklist that IP address or something like that. Realize that when you're dealing with a cell network, you could have 500,000 users all sharing the same IP address because of the network address translation inside the telco's core network. So be very cautious about using IP address as some sort of indicator or a blacklist marker for traffic because of that. Okay, where were we? 4. Finally, the data goes from the core network to the internet. And again, you don't know how that's provisioned, how much bandwidth's there, if they're under attack, if they're screwed up, whatever. So all of this from here and left, everything I just described exists through a mobile network and doesn't exist when you're at work, in your office, when you're at home, when you're in your cable network with Wi-Fi. But users expect their mobile experience to be exactly the same as they would if they were at home on a laptop or on a desktop at work, which makes life challenging for everybody, right? For us. Interestingly, and I hope they fix this since, and there's a link to the report down here, but Pandora was spending 46% of its mobile app radio energy on 0.2% of its data. So think about that for a second. You load Pandora, you start listening to your music, your battery goes flat in no time, you've got to plug it in to listen. And then to find out that 46% of that energy wasn't playing music at all. It was actually handling the marketing data, the beacons coming out of the software, letting Pandora Central know what you're doing, how long you are in your music, et cetera, et cetera. Why? Some of you may have seen this before, but remember we were talking about the radio resource controller? When you start downloading a file, whether it be a CSS, JavaScript, HTML, whatever, your phone has to request from the RRC a channel, which it gets. It then bounces up. This is power on the Y, time on the X. It bounces up, and it starts downloading or uploading data. That's between 1 and 3 watts of power. I think your average iPhone is like a 4 watt-hour battery. So an iPhone could only sustain this for maybe just over an hour if there was no screen on. If you have a screen on, you'd probably run it about an hour. Don't hold me to the numbers. I'm doing it off the cuff here, but it's a lot. It's a lot of power. When you finish transmitting or receiving your data, something interesting happens. It's called the tail. This is the RRC, so the cell network. It says to your phone, keep your radio powered up. You might get some more data in a minute. So the phone goes, okay. And it sits there, burning your battery, doing nothing. By the way, 1 watt is the same as your screen being on. And we all know how long our batteries last if you keep the screen on all the time. So we're burning a lot of power. Anyway, at the end of 10 seconds, it drops back down. So imagine your app or your user swiping because they're waiting for a plane and they don't know which gate it's on or whatever. They keep this alive. They keep it alive for as long as you poll. That consumes an enormous amount of power. So what do we do to get around this? So I'm sure we've all heard of push, server send events. Can I have a show of hands? Has anyone heard those terms? Great. So push, server sent events is the answer. APNS and GCM, we'll touch on that in a minute, of course, use that very same technology. That way, your phone doesn't have to be drawing power, it can just be in an idle state. And then when GCM or APNS sends some data, RRC wakes up the phone, passes the data along, the phone displays a notification, et cetera, et cetera. But APNS and GCM are not two-way. They're not real-time. We'll cover that in a minute. When you get into an application that's monitoring a patient's heart rate, or a doctor in a field somewhere, in the field, who might be looking at telematic data from somewhere else, He wants to see real-time information on his device. REST polling, we've already discussed, doesn't have the performance and scalability necessary for real-time at that level. APNS and GCM are more of a notification system. So when you're dealing with a push-based solution or real-time messaging solution, you make your change like we did before, and then all of a sudden, this magical element here will make sure your phones are updated. So, what options do we have as developers? We've got long polling, which is essentially sending a REST request and expecting it to take maybe a minute before something comes back. And if it doesn't, you open up another REST request. That was great sort of in the 2000s for web apps, but not in our mobile world. HTML5 server-sent events, that certainly is a way for information to pass to the client. However, you're usually responsible for implementing the code for that. Very similarly, HTML5 WebSockets, yes, in fact, almost all the real-time messaging solutions that I'll touch on in a second use WebSockets to get their data to the endpoint. But just having a WebSocket isn't a solution. It's just a data path. You've got to then have a protocol that runs on top of it. You've got to have guarantees. There's all sorts of other stuff that goes with it. MQTT. Anyone here using MQTT? Facebook uses it for their Messenger app, in their app. They don't use it for their web app. For that, they use HTTP long polling, and they bloat the data enormously, and I was surprised by that. But their MQTT implementation for the app is actually pretty decent. Only bloats the data a little bit, keep lives are pretty good. XMPP, anybody use XMPP before? Jabber, anyone use that before? Same thing, yeah. I did too. At ALU, I developed a solution which is running 20+ million concurrent endpoints for various telcos at the moment. It's great if you're dealing with a broadband connection, the inefficiencies of XML, and we all love XML, right? I don't know why everyone's laughing. The limitations of XML when it gets to that point, when you start moving to a mobile network, starts to become apparent. That said, APNS uses XML, XMPP, and GCM uses XMPP for the notifications. Yeah, and I can vouch for this. It's great. You can get eJabberD to run XMPP, you can get Mosquito for MQTT, and then you're left with a whole hell of a lot of work. Because while you'll be able to get the messages moving across, then you've got your performance guarantees, security guarantees, and all sorts of other fun, interesting stuff that you've got to apply on top of that. Then you've got to scale it, test it, patch it, and so on and so forth. Push notifications. We've talked about APNS and GCM. You know, for a lot of use cases, go for it. That's all you need. Use a push notification, wake up your app, it goes and makes a couple of REST requests, displays the data. You're probably good if your app only needs that. And then there's real-time messaging solutions. In no particular order. Actually, I'm lying. That's my company at the top. We've got several companies here, and they've all worked very hard at providing real-time messaging, and it's worth taking a look at all of them. They all have varying features, capabilities, et cetera, et cetera. But there is one downside to getting a mature product. It costs money. Now, the reason I stack this up like that is free and fully functional, but not true real-time and not bidirectional. You can do it yourself, but I promise you it's a lot of work. If you do need a real-time solution, the trick is to then be able to present the business case to management that, yeah, well, I know this costs money, but you're going to have to hire a couple people and keep them employed year in, year out to go look after one of these, depending on what level of complexity you need. So I put a little QR code on here because I couldn't help myself. If there's a video by a guy called Patrick Hammond, and this QR code takes you to it. Wonderful, wonderful video about HTTP2. Because I get asked, this question: why do I need to use product X? Doesn't HTTP2 solve all of this? Well, yes it does, but for web content, for images, HTML, CSS, JavaScript, etc., etc. It's excellent. In fact, it does almost everything right. It uses a single socket, so there's no overhead. Once the socket's set up, off it goes. It multiplexes the data over that socket, so you don't get header-line blocking. You can have stuff being delivered concurrently down the channel. It's fantastic. I love it. It also has something called HTTP2 push. So I looked that up and tried to make sure that it didn't just wipe out half a dozen companies that have invested obviously in real-time messaging, and of course it doesn't. HTTP2 push is for content, not unsolicited data. You've got to have a web page that needs a resource, and part of the handshake for that resource on HTTP2 is, hey, for this you're going to need this file beforehand, and it has to announce that on the response. Now, this gentleman here from Financial Times does a fantastic job of describing this much better than I can, and plus it takes him 45 minutes, and we don't have that time. But I strongly recommend, definitely go and watch that video. But all the arguments he makes for why HTTP2 is great and wonderful for the mobile network is the same argument for real-time messaging for your application. So he provides a fantastic case for why you want to make sure your data isn't using REST polling, and instead using a push-based solution, single socket solution, just like HTTP2 does. Now, how many people have looked into the TLS 1.3 specification? No. I hadn't either until I stumbled across it a few weeks ago. Another great video. What's great is, you remember from the packet traces earlier on, we had 2/3 of our connection just handshake, right? Socket setup, SSL, et cetera, et cetera. Well, TLS 1.3 actually has what's called a zero round trip reconnect, which is amazing. There's some limitations on how it works, but it allows you to drop all of this stuff here. You can get rid of that. It just becomes a get and a response. So you can reestablish an SSL, a secure session, using TLS 1.3. And then, again, great video, lots of technical detail. I think that's pretty cool. Those two technologies, HTTP2 and TLS 1.3, are going to allow, when the servers roll out and the clients roll out and the libraries in iOS are updated and all these other good things happen, it will allow you to take existing REST polling and improve the efficiency quite a bit. But again, it's a polling-based approach. You want to go for a push-based approach if you want to have unsolicited messages coming from the server. But those two technologies, HTTP2 and TLS 1.3, are definitely going to help the world survive over the mobile internet. Kafka. How many people here have used Kafka? How many people here want to use Kafka? I was expecting more hands. So Kafka is very interesting. I get asked this too. Why don't we just use Kafka? Well, Kafka is a pub-sub model, which means to say data is presented in a topic hierarchy. It's really good at ingesting data. It's great for persisting data. It's great for failover and sharding and all that good stuff. But how about delivering that data out to a mobile internet? How about you've got 100,000 phones that want to have the latest weather data for a specific location? How would Kafka handle that? So this is Kafka. This is a packet trace. This is just one packet is this level here. Time across the bottom. The Kafka client, the way it works, and it's described on their website, you have to poll. It's over the same socket, that's good, but you have to poll. So here you are, polling away, bing, 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 and I didn't receive any new data. Nothing changed. I did all that work, and I have to carry on doing all that work to find out if anything's changed. That's not so great. Guess what? You have to do that for every topic. So if you're scanning 10 topics, and you've got one client, it's now 10 packets a second. Scale that up to 100,000 clients, and you can see that Kafka is not very good at delivering the information it's got to the mobile internet. Now, a real-time messaging solution, so just a product at random. I'm not going to give you any hints of which one it is. This individual wrote an adapter to talk to Kafka. most real-time messaging solutions, in fact, I think all of them, are pub sub based. So they have a topic hierarchy tree. It matches Kafka 1-for-1. But the difference is, this is what happens when no data is transferred. You have a keep alive packet, keep alive packet. Remember that conversation about the network core from the mobile network? You've got to have some keep alives, because otherwise they'll shut down your socket, and they don't inform you, by the way. They don't tell you. They just let it disappear silently. So the server and the client have no idea the connection's gone. So you've got to send probes out to keep that alive and know that it's still alive. Here's one packet of data. So I made one change and it got transmitted here. That's efficient, right? Do you remember we blew through 30 packets just to get that 1 kilobyte of data earlier in the presentation? That's what it looks like when you're not polling. And remember, this is way better than REST because it's the same socket. Huge advantage, much less power, a lot less processing.
You have to be careful with Kafka when the queue's empty, not to just be in a tight limit.
Yeah,
Or else
and
you're just hammering it at your CPU.
yeah, yeah. These things go away when you've got a real-time messaging solution, because that bridge can happen in a server side or a data center. That's fine, you can deal with that inefficiency there. But then if you've got a real-time messaging solution, it will automatically just go, oh, it changed. I'll actually send that now to only the people who subscribe to it. Way more efficient. And again, this could be one topic, 10 topics, 100 topics. You only get a packet when data changes, which again makes things very, very efficient. And when you're in real-time messaging, it'll actually combine all the changes in a batch and transmit it out. So next question is, oh yeah, okay, so you got proprietary solutions, you have to pay licensing fees, et cetera, et cetera. What's the internet doing about it? Well, they're actually working on this. So up here, we've got the push API from the W3C. We've got some code here, which subscribes and gets data. It's fantastic. It uses something called serviceworker.js. So that's a new feature in browsers that allow you to write code that runs headless in a background thread on a browser for a web page. It's pretty cool. And I'm sure we're going to see some abuse of it. But for Service Worker, it can give you the W3C push API. This is draft at the moment. Google's implemented it. I think it's exciting. It's going to, I think, bring real-time messaging to a lot more applications just by sheer uptake from Chrome. I'm not sure if Firefox supports service workers yet, but you get the idea. As this progresses, as it starts to hit mainstream, we're going to see a lot more use of it. But you need a broker. This is just an API specification. There's no server technology behind it. So just bear that in mind, that when this comes out, there's then going to be a race to provide brokers that actually feed data to this API. Of course, Google's going to have an answer for that with GCM. So you need a protocol, and they're working on that too. IETF has got a web push protocol here. This is what it looks like. Fantastic. I love the formatting of these RFCs. They're very enticing. I don't know how many times I've fallen asleep to these things. It's incredible. So they've got a protocol. It's in draft. Pretty cool. It's got all the overhead that you're used to with HTTP. So you've got content type, topic, TTL, this is great stuff. With HTTP 2, that's going to help because you can use HPAC. That'll reduce it. That'll be good. There is another draft spec alongside this based on CoAP, which is a more byte-level protocol, much more efficient for IoT, et cetera, et cetera. This is coming along nicely. Again, you need a broker to talk that language and actually do all the value add, right? So the security, the authentication, the keep alives, all the stuff that you need in a real-time solution. But this is great. This is going to help push the field forward. They're still draft. I mean, they're literally updating almost twice a month. So I have to mention microservices just because, right? I have to. I'm bound to mention microservices. So where does this all fit? So we're used to 3-tier architecture, right? Client tier, aggregation tier, what we used to call middleware. This is what's going to grab data from different services, databases, do your munging, and then present the information out to the client. We've got the service tier, that's external services, internal services, et cetera, et cetera. Why am I talking about this? I really like the phrase 4-tier architecture. which was coined by Ted Shadler from Forrester. In the delivery tier, we've actually had it for a long time. CDNs, so content delivery networks. They've been doing that for, what, 20 years, right? So you have your website, you want to go fast, you stick a CD in front, give Akamai a ton of money, and they do help. It's actually pretty good. You've got reverse proxies if you want to do it yourself, Nginx and Apache. I mean, how many of you have had an Apache sit in front and then send requests out to different backend servers? One. 2, 3, there we go. So yeah, you can do that. APNS and GCM, if you think about it, they're a delivery tier for your application. They allow your server to get a message to your client, so they go and deliver that to your endpoint. Real-time messaging solutions has been noticeably low uptake for applications, and I think part of that's a PR problem. People aren't totally aware of all the different solutions that are out there, and of course they're all competing. But if you think about it, we've got APNS, GCM, reverse proxies, CDNs. Why not have a real-time messaging solution as part of your product where you need to stream real-time information? Okay, this is the last slide. Please pepper me with questions here. So, things to consider when you're looking at a real-time messaging product. Time to market. You can build it yourself. You can take eJabberD, you can plug in a server process that communicates over XMPP, go figure out all the stuff, handle authentication, and so on and so forth. But if you need this to be working next week, by the way, how many of you are under tight deadlines? See, it's laughing again. Cost to develop. Okay, so this is a big deal. Cost to develop, support, and maintain. So when you build something on eJabberD or any other WebSockets, use Netty or whatever you want to use, there's a huge amount of cost to it. And it isn't the development cost. It is rolling out into production, making sure you got monitoring for it, making sure it stays up. You getting woken up at 2 in the morning on a Thursday because something's happened. It's very serious, very real. Security patches. So what happens when a TLS protocol gets broken? You've now got to go and change out your solution, go figure some stuff out. Maturity of a security model. So is it fine-grained? Have you got security on a per topic basis, per message, per endpoint, all of the above? Is it extensible? Can you integrate it with different backend systems, et cetera, et cetera? Is it on-prem, or is it cloud only, or is it both, right? So on-prem, you obviously save yourself cloud fees, but on the cloud, you don't have to worry about it. You're just firing up an instance and running with it. Caching of data. So does your real-time messaging solution actually cache the information? So APNS and GCM don't cache information. If your phone misses the message and APNS stops trying to retransmit it, you can't go and get it unless it goes back to your original source. With a real-time messaging solution, remember that 4-tier architecture? It's got one trough to go and feed from, no matter whether it's getting for the first time, getting live updates, or just subscribing to new topics. It's right there in that delivery tier, ready to go the whole time because it's cached. So it's a very important criteria for any real-time solution. Reliable connection for unreliable network and roaming. So when I leave this building, I'll go from Wi-Fi to LTE. What happens to your socket? Just gets wiped out. Just gets wiped out. So you got to reconnect. Well, how about the messages that were waiting for you, right? You've got to go and build all that logic into your client and your server to go retransmit the information that was missed. And there could have been stuff over the air that the server thought it sent and the client hasn't received. So you've got to go think about that too. So when you're looking at a real-time messaging solution or building your own, you've got to handle this handoff, this transition between Wi-Fi and LTE. And do it in a way that makes your application not have to worry about it. Automatic throttling of data delivery. I'm not going to read the rest. Your endpoints, they could be resource constrained, they could be in that NFL stadium with everyone posting selfies to Facebook. Your solution should be able to decide, okay, I can drop intermediate data. For instance, patient's blood pressure. You can drop that it went up and down if the value of the information is timed out. Now, it's great if you're monitoring and you've got a great connection to see that movement. But if the endpoint's slow, if the connection's shaky, your real-time messaging solution should be able to detect that, detect the back pressure, make a smart choice for you without you having to write any code, and go and deliver just the latest information. Linear response time as you scale, right? Well, of course, right? If you've got 100,000 endpoints, you still want it to be 10 milliseconds to get that information to your phones. You don't want it to take 5 or 6 seconds. This is really important. There are benchmarks that we've run that show some solutions will go hockey stick once you get over maybe 20,000. So you write your code, everything's looking great with 10 endpoints, 15 endpoints, and then as you scale it out, you're gonna find you've got a slower response time. So that's almost the first thing you should do whenever you're trying a product is go and scale out. Go see with some load test clients what happens when you throw 10,000 connections at it and see if it still maintains its response time. Data efficiency. So getting stuff over the wire that's congested, et cetera, you want to compress it. You can use gzip compression, but the really fun stuff happens when you start doing time series compression. So if you think about a JSON object, right, and it's got patient's name, location, attending physician, maybe the nurse there at the time, and then let's say you have the blood pressure, heart rate, and a few other statistics, VO2 stats, et cetera, from second to second, or half second to half second, or quarter second to quarter second, only a little bit of that JSON object is changing. Only some numbers down here. All the other stuff's the same. So you don't want to go and compress all that and retransmit it. You don't want to transmit the whole thing for sure, which you'd be doing with a REST polling solution. Time series compression is cool, where you can actually look at the data through time and make a smart decision, only transmit the data that's changed. And there are products that do that. Super efficient. So now instead of having a 2 kilobyte JSON object, you're only transmitting 8 bytes plus a little bit of overhead to communicate what topic it's for. That makes it super efficient on congested networks or remote networks. Or if you're, you've got an operator running a drone out in the field and it's being monitored, somewhere way back in, say, Houston. In the field, you're not going to have a great connection, but you do need real-time information. You need to know maybe it's GPS location. Maybe you're collaborating with the operator. Being able to transmit the coordinates for where your pen is on a tablet or where the drone is in the location over a unreliable and resource-constrained connection, if you can time series compress that data, you've got a very powerful tool. Native support, I won't go into that in too much depth. Configurable keep alive intervals. Cell phone networks have a 10-minute TTL for their NATs, give or take. Other networks have different timeouts, so you can adjust those. So you definitely want to be able to configure those keep alives because they will ultimately burn up your data plan, right? Or congest your own data feed. Reconnect and backup algorithms. So, okay, so you've got, and this is a very real problem that I had to make sure I had in place, the solution in place. If you've got 10 million concurrent connections and your hosted services team want to do a rolling restart of all the servers that they're connected to, what's going to happen? Right? You're going to get them all reconnect. And if they do it all at once, they basically distributed denial of service your solution. And then your hosted service team isn't very happy with you. So you don't answer their emails or their phone calls for a few days. The alternative, of course, is to then go and make sure the backup algorithm follows some sort of procedure so that they all stagger back in a reasonable amount of time. So again, any solution you pick, or if you write your own, you've got to make sure you have a configurable backup algorithm that doesn't DDoS your infrastructure. And more, which means it's time for me to get a beer and to field questions. So please, fire away.
Where are those keep alive intervals like specified? How did you figure out that was 10 minutes?
So research, mostly. You can find reference points on the web, but always test it. 10 minutes is the maximum. So cell phone networks, if we don't see any traffic over a TCP socket, we'll just drop the mapping. They won't send the RST packets out to both ends to let them know that socket's gone away. Same thing happens with residential gateways inside the home. So those little firewalls, they have fixed tables, usually 2,000 entries. If you have a connection that's been open a while but not active, it goes to the bottom of that 2048 and they just drop it. Now in your home, you're not going to have that unless you've got a lot of people or you've got certain games or applications that keep on opening and closing sockets. But more common is after about 30 minutes, those gateways will just drop the socket. they'll think the endpoints have just gone away. So you need those keep alives, but you don't want to have too many of them as well. So you've got to be able to configure that for your situation. So mobile networks, 5 minutes is probably a good starting point. You might want to do a little bit of real user monitoring just to see if that's correct. But one of the research papers on this slide deck, one of the links there, and it might be the 400-page PDF, which I've made it halfway through, has some more details on that.
On the server side, how would you manage like 100,000 connections? Socket, like HTML5 sockets.
Right. So let me give a reference point. So 1 million concurrent connections for Linux, Box, CentOS, Red Hat is easy. You've got to get the network stack configuration loaded in correctly. There's a lot of tweaking and stuff you've got to do for that. Once you've got that in place, then you need a server that's based on asynchronous technology, right? So not threaded. So eJabber uses Erlang, which is on the Beam VM. It's capable of doing that. Netty would be the equivalent in Java. The company I work for, they've hand-coded various constructs, including non-blocking locks. So they don't use synchronized sections to go and manage this. It's a hard problem. But we can go up to 1 million. A lot of the other solutions can go up to 1 million. But to do it yourself, it's a fair bit of work. But 10K, 50K, you can probably get away with relative ease.
Are there any advantages over one VM versus another when it comes to real-time messaging? I know Erlang's was built in telecom, and the whole point was to be able to handle massive concurrency. Is it still the leader in that space, or are other languages and VMs catching up to it?
That's an interesting question. So yeah, Erlang started, it wasn't actually sanctioned either in Ericsson. The guy just went off and wrote it, then they fired him for writing it, and then he started up a company, and then they decided to hire him back. So the history of Erlang is very interesting. I've worked with Erlang. I'm not a fan because of the way it works. I mean, it uses 4 bytes, I think, for every character or something for strings. I don't like that. But its programming model with actors is pretty cool, and messages. Of course, Akka and Scala were modeled after that. And my understanding is they get pretty darn close to matching that. And then you're on a Java VM, so you've got all your creature comforts there and libraries you can talk to. So I'd say the most important part is not having blocking sections, so no synchronized sections, no locks. So lock-free programming is the most important aspect, which with Erlang and Akka, they achieve through immutable objects and a few other things like that. So it's all message passing. So I think everything's caught up depending on the space you're in.
Have you seen much Elixir in the real-time space yet, or is that still kind of off on the side?
I've tinkered with Elixir briefly, and the person showing us it said this is so much easier than Erlang as a language. I agree, it is easier, but still, as I've been a Java programmer for almost forever, so I still struggle a little bit with having to do tail-end recursion to iterate through a loop. I don't know. Yeah, just write a 4, please. So I think a lot of people like that. But again, you're event-driven, no locks, message passing, actor model, again there. So I think there's advantages there too.
I'm a non-technical founder. Could you describe the debt when you move from polling to then the push? Like, what is that debt? What does that cost?
Okay, so here's the best part. You don't have to boil the ocean. So what you can do is you can start with looking at your API, REST API, and go, actually, look, most of this stuff we don't need to be real time. So don't upgrade it. Leave it alone. What you can do is say, look, hey, these 5 API calls here need to be real-time streaming, and we need the efficiency. So you bring in the SDK of the real-time solution you're going to use. You then just make a call over that for the same information, or subscribe to a topic, right? On the server side, if the real-time messaging solution allows dynamic topics, that's where you subscribe to something that doesn't exist right now. If it supports dynamic topics, it could receive that, hey, there's no topic. It could then go and construe from that, oh, I need to go and fetch this data from this REST path from a traditional REST server. So you can have your streaming data feed across the mobile network, and you can just use traditional REST with your existing server infrastructure, so you don't have to change your back end. Which is why I touched on that 4-tier architecture, right, the delivery tier. The idea is you don't have to change your back end. What you do is you have a delivery tier that makes sense for content, CDN, for real-time messaging, so you'd have a solution for that, and you microservice it. So you only route the stuff that needs to go through that API through that real-time solution. What's interesting with PubSub, real-time messaging, and REST is this. A lot of people will write a REST interface and make it resource-oriented, right, because that's what they say for REST. And then the next thing they do is they go, well, we have to make 6 calls to get the data. Why don't we write a URL that wraps all this in one great big blob? And I've done it. And then performance is amazing, right? When you've got a real-time messaging solution, you can subscribe to 6 different paths in a topic tree, which is analogous. In fact, it's an exact mapping to your 6 paths in your REST resource hierarchy. Well, the real-time messaging solution will make sure that when you subscribe to that, you get your squirt of data with everything you want, all in one burst, on one socket, without all the overhead. So it's interesting, PubSub is actually more REST than REST. And if you have a PubSub solution and you map it to your existing REST hierarchy, you actually get the best of both worlds. You don't have to write these blobs that represent a whole lot of data. And now you can get fine-grained updates. So instead of the big blob, one thing changing here, you're only getting these delta updates or just the individual update for that topic. So what's great about PubSub and any sort of real-time messaging solution is, like I said, it's more REST than REST itself, or the way it's implemented, I should say, today, to work around its inefficiencies.
Very cool, thanks.
Yeah. Great.
All right, thanks. So, a couple things before we wrap up. One, we've got a few minutes. Yeah, we got a little bit of time. Let's do this. Cool tools or APIs, things that you've seen or come across. Anybody come across anything interesting they want to share? I'll go first. This isn't necessarily an API, but I've been thinking about using it with an API, but it's a tool. The place I work at is a Node shop, so we use a lot of Node stuff. And it's a tool called Vorpal, I think. It's from the one of the crazy poems. It's not Seuss, but reads like a Dr. Seuss poem. Anyway, it's a tool for building out like custom shell prompts. And I keep looking at that and going, this would be so cool to build into, like, here's a shell, you launch into it, and as you type out strings, it just goes to your API and pulls it in. You embed that into something like iTerm where you can display images, and now like you get images of graphs and things that are happening. So I think that's a cool thing. It's one of those things, it's a solution in search of a problem right now. I want to figure out a way to use it. It's like, this is really cool. Anybody else? Nobody seen anything cool in the last month?
Actually,
Oh, here we go.
yeah, I've got one. So
You don't have to come up here, by the way.
oh, I'm gonna anyway. Sorry. Now I got the beer in my hand. I'm more comfortable. How many people have dealt with forward security on SSL? Anyone run into that? Okay. I won't go through the details because I've only just read about it. I haven't actually implemented it. But the upshot is that you can't just take a private key and decrypt some traffic. Okay? So it makes it really hard to go and figure out what's happening in a web browser, for instance, talking to your backend server that might be secure with SSL, especially over HTTP2, that has to be SSL. So the cool tool is in Chrome. You have to look it up. It's on the web somewhere. In Chrome, you can tell it to go and store the cipher keys that were negotiated for the data that's being transmitted. Basically bypassing the need for public key cryptography to decrypt the traffic, so you don't need a private key now. And Wireshark supports reading that file and the packet trace and decrypting it all. So you can go and discover what's going on inside HTTP2 over the wire.
Okay.
And you don't have to do it two at the same time. You can packet trace on the server over there. You can get your log file from Chrome over here, put the two together.
This seems like has a lot of potential misuse.
Yes.
Why would you say that? Yeah, it could. It's off by default.
Okay.
In users' browsers.
And it, please tell me, gives you this huge warning saying, you really don't want to do this when you enable it?
I don't know. And I don't know if it tells you if it's on while it's doing it.
Oh, jeez.
Awesome.
Was that a cool tool?
No,
Go to the back of the room now.
Anybody else?
Yeah, I just stumbled across JSON dash generator. It's like a beta, like you can give it like a kind of like a description of what kind of JSON object you want, and it'll create you some random objects based on the information you said.
Ooh, that'd be good for fuzz testing an API.
Yeah, I use it to push some messages into my queue that I was trying to test.
Cool. Does it read Swagger files or specification files?
Not that I could see. It has kind of its own little language that you kind of define an object with this dictionary. You know, if you want to create an ID, you can specify a GUID or different types of things. And then, yeah.
Cool.
Sounds like a great project to tie into it, something that reads a Swagger file and generates that code.
There's a library called Liberator for developing REST APIs. It's based off the Erlang web machine, and so it provides this nice little graphic, which is all SVG based, to show you the decisions that you go through to get a REST response. And so you get access to the full set of response codes in these nice little declarative functions that you can code in. It's really easy to work with. It's a closure, it's open source.
Erlang is one of the languages I've yet to get paid to work in. I always
Sure.
wanted to. Like I learned it, it's like, this is really fun, and then like I never been able to use it. Anybody else?
And it highlights each of these steps so you can see like how it goes through the decision graph, which is really nice when you're debugging.
That's cool.
Yeah.
It's called Liberator?
Yes.
Nobody else? All right. Well, just keep a file of like Evernote or Google Keep or whatever you use for your notes for January. The last thing before we go, who's hiring, looking to be hired? We'll start with who's hiring. Anybody got positions that they're hiring direct for? Just a quick, like, who I am,
Sounds
what
good.
I'm looking for, what the company is.
Cool. I'm the founder of ClaimBot. We're building a chatbot platform for insurance carriers. Have one paid customer, bootstrap, launched in May. Looking for a technical lead.
Bankrate Credit Cards /creditcards.com, looking for web services engineers, as well as some people to work on a PCI DSS compliant consumer platform with financial data. I'm mostly front end, so I don't have a ton of details, but I can put you in touch. Also data engineers, please data engineers.
Anybody else? I'll go. Condé Nast. We're hiring, let's see here, we've got a data engineering position open, we've got a DevOps position open, a couple of front-end positions open. We're a node shop, so looking for the mythical full-stack JavaScript developer, but also people who are focused on front-end, people who are focused on data science, more on the Java, Python side of the world, and then Node, since it's not great at that. And just people who are interested in working in the JavaScript space. If you like media, that's a good thing. We're a media company. So.
What's the name of the company?
Condé Nast, the shirt I'm wearing.
How big is Condé Nast here in Austin?
We're 22 right now. Engineering team as a whole is 150-ish, but we just opened an Austin office earlier this year.
That's cool.
Anybody else? Anybody looking to be hired? Same thing, who you are, what you're doing, what you're looking to do.
David Mathis. I have been kind of a CTO or just full stack for the last 7 years with a startup company that never got past startup. But full stack would really like to be in the Node.js space, but have done a lot of different things in the past.
Anybody else? All right, so everybody that's looking to hire, go mob this one. With that, we've got the space for another 30 minutes or so. There's still some beer, a couple of Diet Cokes back there. If you want to hang out and chat, please do. Thanks for coming. Hopefully we'll see all of y'all at Awabash, and then again in the new year.
Yeah.
Hey man, how's it going?
Right, the bash is, they got some. But the all bash is once a year.
Yeah?
You know what Buffalo Billiards?
Yeah.
They
You know what? I remember
rent
seeing
the
that
entire
on
building.
Facebook or LinkedIn.
Nothing but
I
nerds.
knew some people who were
It's
there.
fucking awesome.
The
It's
guy.
free and they have an open bar.
Yeah, I remember everybody told me the name of the company. It was like Big Commerce. I'm like, no, okay, that's what you need. What's the name of the company? No, Big Commerce.
It's one of those,
Yeah. How's that going?
It's going alright.
How long you been there?
Almost 3 years.
Really?
It's gone by really fast.
Well, yeah, okay, I think about the last 3 years, that totally makes sense. It either seems like it was forever ago, or
Kind of both. And like also for a while there, up until about this time last year, like our office, our main office, like up at 620, 22, and it's like I'd never make it down for like meetups or anything. It was, so like across the street. Yeah. I'm working on like a rails, and I was like, okay, I have to go to something else.
So you guys are coming.
Right, well, because like I got